So this video is going to go over the free response part of Unit 2A test. So on FRQ 1, you're always either going to have a function represented by a graph or a table, and then you're going to have a function represented algebraically. And they're not going to be related. We will use both of them on part A, but they really don't have anything to do with each other. And so f is a function that consists of line segments that are connected, and its domain is between 0 and 8. And then g is an exponential function. And so A1, we have another function, h, that's defined as g of f of x. And we want to find h of 2, and h of 2 is g of f of 2. All right, to find f of 2, so we always start on the most inside, and to find f of 2, we're going to need to go to the graph, and when x is 2, f is graphed up at 3. So f of 2 is 3, so now this becomes g of 3. And then for g of 3, we want to use the function. Now, I think it's a good idea, because we'll use this many times on this particular FRQ. It's a good idea to type this g into the calculator, into y equals. All right, and then if I want to find g of 3, there's different things I can do. I can go to the table, or from the home screen, I can do y1 of 3. And then we need to make sure that we are accurate to 3 decimal places. So we can either give the answer as 2.641, which is perfectly acceptable, or 2.642. Or if you wanted to, you could go to all the decimal places, or you could go to 4. But you need to just make sure your first 3 decimal places are accurate. All right, and then for part 2 of A, we want to find all the values of x for which f of x is equal to 6. All right, so remember f is the graph, the function represented by the graph, and 6 is up here, and the x value when f is equal to 6 is going to be 7. Now, all you technically have to do is answer 7. I feel like when you write out the sentence that you kind of double check yourself that you really did answer the question. So I think it's good practice to write it out. But again, all you really have to do is put 7. On part A, or A part 1, you do need to show all these things. You can't just give the answer and just do it in your head and give the answer. So make sure you are showing your work on A part 1. All right, B part 1. We're going to find all of the x values as a decimal approximation for which g of x is equal to 6.5. So remember, g of x is the exponential function that we have typed into our calculator in y1. And so if we want to know when this is equal to 6.5, we can make y2 equal to 6.5, and then find where they intersect. Okay, I'm going to change my window a little bit because I was doing something else, obviously, last time I did this. So zoom 6 will always get you to a 10 by 10, or negative 10 by 10. All right, so we can see they cross right here. And so we're going to second trace number 5 and hit enter 3 times. Now, if they crossed at 2 places, we would need to move close to one of the intersections and hit enter 3 times, but this one, they only intersect at 1 point. So if this says intersection, that's going to be the answer. All right, and so I would say something like g of x equals 6.5 when x equals, and then we're going to need to be sure we're accurate to 3 decimal places. So you can say 1, or you could say 2, totally up to you. Or you could do the whole number. part 2 of B. We're going to determine the end behavior of G as x increases without bound, and we're going to express our answer as a mathematical notation of a limit. So if x is increasing without bound, x is approaching infinity. We also need to just remember that the one on your test might not be increases without bound. It might be decreases without bound. So just pay attention. If x decreases without bound, they're going to be x is approaching negative infinity. So x is approaching positive infinity on the right side of the graph. And on the right side of the graph, G is increasing, so it's approaching positive infinity. Now don't forget that we have to do the 4 parts of the limit. And if this is asking about G, that needs to be G there. If you put F there, you do not get your points. So the 4 parts of the limit are the limit, what x is approaching, the function, and then basically what y is approaching. All right, and then part C, we want to know if f has an inverse function. Another way that could be asked is f invertible? They mean the same thing. And as long as f will pass the horizontal line test, then f is invertible, or f does have an inverse function. You technically could get away with just saying yes there, but we're going to practice perfection. All right, and then we're going to give a reason for our answer based on the definition of a function and the graph of f. So we cannot say f has an inverse function because it passes the horizontal line test. You can, but you won't get the point if you do that. So we have to say something similar, or very, very similar to f is invertible, or you could say has an inverse function because each output value of f is mapped from a unique input value. Now on your test, it might be no. The answer might be no. And if it is, you would say some output values of f are not mapped from a unique input value. And then you have to give an example. So if it's no, you have to give an example to earn the point. All right, so that's for your response question 1. That'll be 1 point each, so 6 points there. And then we have free response question 2. It's also 1 point each part, a total of 6 points. Some of these points are way easier to get than others, but I want you guys to study and try to get all 6 points. But on this question, a biologist began studying the population of elk in a protected wildlife reserve in 2010. In 2013, when he was 3, there were 48 elk. In 2022, when he was 12, there were 235 elk. A population of elk can be modeled by this function, which it doesn't tell you in the words, but that is exponential. Hopefully you know that because the t is an exponent, and that's the independent variable here, where p of t is the population of elk during year t, and t is the number of years since 2010. All right, we're going to use the data to write 2 equations that can be used to find the values for the constants a and b in the expression p of t. All right, so we have 2 data points. One, when t is 3, the elk is 48. So we put the population of elk in for p. A and b are a and b, and we put t in for t. That's kind of obvious. All right, and then for the second set of data points, the population of elk is 235, and t is going to be 12. All right, and then for part 2, we're going to find the values of A and B as decimal approximations. So whenever the exponential model, I guess, looks like this one, where it's just AB raised to the t, we can use our calculator to find it by going to stat and then edit, and this is not this. And then we go to stat, over to calc, and then we're going to choose 0. Now I went the long way to choose 0, but that's okay. And it's a good idea to store it because we might need it. Again, I'm not sure. Okay, and then they don't want you to do anything fancy here, really. They just want you to say A is 28.268 and B is 1.193. And you can go to more decimal places again if you don't have to. Okay, and then for part B, I feel like those 2 points are really easy to get. Part B, it's not too terrible either. Or part B 1 and 2 aren't too terrible. 3 and then part C get a little more challenging, but you can still do it. So part B1, we're going to use the given data to find the average rate of change. Now, of the population of elk from t equals 3 to 12. Okay, you do have to show your work here. You can't just do it in the calculator and give the answer. So we're going to subtract the number of elk on the numerator and then the years in the denominator, and then that you can type in your calculator and you would get 20.77 or 20.777 or 20.778. It doesn't matter how you do it. And I'm going to write that this is elk per year. You do not have to write the unit there. They tell you the unit in the problem, but it helps to do the next question if you do write the unit. Okay, and then for number 2, we are going to interpret the meaning. So an interpretation doesn't mean you say the average rate of change. You don't just state the answer. You have to say what it means. And so to help with what it means, we can use the NUT method. And so the noun is the population of elk. Now I do like to start off, if it's the average rate of change, to start off with on average. You don't have to, but that's best. But on average, the noun, the population of elk. Is, and then you need to tell if the population is increasing or decreasing on this time span. And since it is a positive, we're going to say is increasing by 20.777 elk per year. That's the unit for the elk per year. And then we need to do the time. So between t equals 3, and t equals 12 years. Okay, that is an interpretation, not just a statement of the answer. All right, and then part 3, the average rate of change found in part 1 can be used to estimate the population of elk during year t for t between 3 and 12. Will these estimates found using the average rate of change be less than or greater than the population of elk predicted from the model P between 3 and 12 years? All right, so we need to know if this graph is concave up or concave down. Now, I know what it is because A is positive and B is greater than 1. It is going to be a graph of exponential growth. You might want to look at it on the calculator. If you stored it in Y1, that is just a very small portion of it. So I'm going to just, we're just looking between 3 and 12, but I'm going to go higher. We'll go longer. See what happens. Okay, that's still not great. But we can tell it's concave up. All right, so what I would do is draw a concave up graph. Oops. And I would label it P. That's our model. That's the model we found here, where that's A and B, and the A and B is put into that. That is that equation. All right, and then we have the average rate of change that we found is the slope of the secant line, where T is 3 and T is 12. All right, so the estimates using the average rate of change are going to be values on the secant line. And then the population using P to predict the number of elk is going to be on this pink line. And so between T equals 3 and T equals 12, the estimates are going to be larger. The estimates from the average rate of change are going to be larger than the predicted from the model because the secant line is above the model on that section. All right, so in this we have to mention the secant line. We have to mention the concavity of P. And we have to answer the question. So I'm going to start by answering the question. It says these estimates, the estimates found using the average rate of change be less than or greater than? So I'm going to start off with these estimates. I'm going through the problem found using the average rate of change. Are, and then we're answering the question greater than. I'm still going. The population of elk predicted by model P I'm still going to go during years T for 3 is less than T is less than 12. All right, that's answering the question. And the reason is, we have to explain our reason, because P is concave up and the secant line through T equals 3 and T equals 12, I'm running out of room, will fall above P when 3 is less than T is less than 12. All right, so this first part where I'm just quoting the problem is just answering the question, greater than. And then the second part gives your explanation, which has to involve concave up and secant line in this situation. All right, and then part C is also a tough point to get, but it's gettable. For which value of T? T equals 8 years or T equals 25 years should a biologist have more confidence in when using the model P? Give the reason for your answer using the context of the problem. So the context of the problem is about elk, and so I would start off and just say that answering the question, the biologists should have more confidence in T equals 8 because T equals 8 falls or is within less than t is less than 8. Sorry, 3 is less than t is less than 12. T equals 25 is outside the data. And we do not have any information about the change in population of elk. So there could have been like a drought, severe drought. There could have been some disease that goes through the elk, and we just don't have information there. So any data points that falls in between our range of data, then that you can have more confidence in than anything that falls outside of it. All right, study up. Good luck on the test.